welcome. We are going to talk about, I'm going to talk about security in Azure specifically for the next 45 minutes or so, 50 minutes or so. We'll see how it goes. And there's a lot of things that I want to talk about. We're talking about security because obviously we're at a security conference this week, which is fun. But it's important to kind of think about why security matters. And so just a few refreshers, water is important and good water is important. So security matters. My personal information and financial information is important and sensitive and oftentimes private for me. And so it matters. Not only does it matter for me, but it matters when I am an Equifax of the world or a Home Depot or a Target, and I have to pay hundreds of millions of dollars to have Visa and MasterCards reissued to everyone who had their cards compromised. So it's important in lots of ways. And then, I certainly don't want oil, gas pipelines doing wild and crazy things. So just a couple of reminders as to why what we're talking about is important. Now, why am I talking about this and specifically about Azure? Well, I'm Eric Boyd. I am a 12-time Azure MVP, which means I've been working with Azure for a very long time, and I do this kind of thing a lot. And in fact, that's how I met Michael years ago is at Azure events we host in Chicago. And so that's why I'm here. I'm also a Microsoft regional director. Now, I say that to say I don't work for Microsoft. I am an independent voice. I have close relationships with the product teams and with leadership at Microsoft, but I don't work there. So I can tell you the true Hollywood stories as it relates to Azure. There's my email address. There is me on X, Twitter, whatever we call this thing today. I give you that. Feel free to email me after this if you want copies of these slides. If you have questions, if you want to drill into something even further, feel free to shoot me a message. I say I've been doing this for a long time. For those that have been in the Azure space for a long time, do you remember this? I was there at PDC 2008 when this got unveiled to the world. Windows Azure, the Azure Services Platform, the Microsoft Professional Developers Conference, if I should probably not use acronyms all the time. But I was there at the beginning in 2008 when this first started. I saw potential in the cloud in this way at this point in time. This is what our original portals looked like. In fact, that's what our original portals looked like. So it was wild. There were like 3 services in Azure at the beginning. And they weren't VMs, by the way. They were like, give us a package of your application and we'll run it for you at internet scale. But there's not anything else to support it really. So that was what Azure started out as. Now, I've been in this game for a long time. I then said, this looks promising. And so I'm going to hitch my wagon to this game. And I started a consultancy in 2012 called ResponsiveX. And all we do is Azure. Since 2012, we've not done a single project with customers around the country that didn't have to do with Azure. We focus in these 3 big areas, and we wrap everything up in kind of DevSecOps. And so we're huge fans of automate everything, infrastructure as code, all that good stuff. Today, we're doing a lot of work in AI, which is a lot of fun. We do a lot of work in massively scalable distributed systems. So when you order coffee from your phones, we help build systems like that sort of thing. So we talked about the incidents that are bad, but these are the things that we're really protecting. When we zoom out and think about what it is as security professionals that we're really protecting, we're protecting people and living things, employees, customers, partners of organizations, livestock, potentially, pets. I know it seems like people here love cats. Cats kill me. I'm like allergic to cats, and like literally they kill me. But pets are a wildly popular thing here at CypherCon. And so we're protecting those kinds of things, and we're protecting resources, money, inventory, facilities, all that good stuff. So it's important to keep that kind of in view. When we talk about the Microsoft Cloud, it gets a little confusing. So I want to lay out a few things for terminology purposes. I break up the Microsoft Cloud in 3 distinct areas. Microsoft 365, what we used to call Office 365, what we used to call Business Productivity Online Suite. Microsoft's great at renaming things all the time, and so next week it'll be probably called something else, but today we're calling it Microsoft 365, and that's the productivity collaboration tools that we love, or maybe not, in the Microsoft ecosystem. Then we have Dynamics 365, and that's all the business solution kind of tools, CRM, ERP solutions, that sort of thing. And then Azure, that's where we really want to focus on today. And this is the platform and infrastructure services that we use as technology professionals to run workloads, create, build, deploy applications for our organizations. Now, we're going to throw around some buzzwords today, especially as it relates to security. So we'll talk about defense in depth. We'll talk about least privilege, zero trust, all that good stuff. But when we think about defense in depth at a zoomed out high level, and I stole this from Imperva, so I'm giving them credit here at the bottom, we're really thinking about these big areas: physical access, technical controls for both software, hardware, and just administration and governance and security policies. So that's how we kind of break it up. Now, the good thing is when we're thinking about the cloud, we no longer really have to concern ourselves with that huge chunk of the pie that is physical access. It's not our problem. We delegate that to a vendor. We have to kind of do some due diligence and make sure they're doing the right things and check what they're saying they're doing. But we don't have to worry ourselves with that. So then I stole this one as well, which is another great view. And again, you can go grab this off of Twitter as well, or X, or whatever we call this again today, of defense in depth and the things we have to concern ourselves with. So it's a little more detailed with lots of call outs in all these big areas. And it's important. I think the way it's visualized here is really important as well, with kind of these cross-cutting concerns in green off to the side at the bottom. When I think about security, I like to use the metaphor of a castle, a fortress with all these great security measures in place. And so this is how we'll dive into this going forward. When we think about this castle, there are a few kind of foundational principles we want to adopt in our security posture. We want to first begin with a solid foundation. We want to have a hardened fortress. We want to reduce our surface area for attack as much as possible. We want to have strong gates. We want to have layers of security, defense in depth sort of things. And we want to have that communication going in and out of the gate being secure. So this is the metaphor I always use when talking about security, because I think it just works really, really well. With that, let's talk about solid foundation. We're going to, again, specifically talk about Azure. I'm going to talk about things that you may not think are specifically related to security, but I think they are extremely important as well. First thing, that physical data center. That physical Azure data center that we don't have control over, we trust a vendor has control over. This is what one of those data centers looks like. Who in here is from Southeast Wisconsin or Northeast Illinois? Okay, cool. We're actually getting one of these. We have one of these already in Chicago. You may or may not know about it. Anybody been in the Chicago Azure data center before? Okay, I have two. I'm a super lucky guy to have gotten to go in the Azure data center early on. You would never know it's a Microsoft data center. There's no sign out front or anything like that. The only giveaway is like this massive power substation that's like attached to the building essentially. And they're one pole off of this power substation. But they're building one of these in Mount Pleasant, Wisconsin, which is where I live. I'm one of the 25,000 residents of Mount Pleasant, Wisconsin. And we're getting one of these data centers, which is amazing. They bought like 1,000 acres of farmland. In fact, if you were a farmer in Mount Pleasant, Wisconsin, you got to sell your land for $185,000 an acre. Yeah, my son, my middle son, who's 12, is a dirt bike guy, and he's always on me to buy some land for dirt biking. And it's like, dude, we can't buy land. We can't compete with all of these people buying land for data centers and warehouses and distribution centers and stuff like that. So we're going to get one of these in Mount Pleasant, or several of these, and they have various mechanisms for deploying infrastructure. They have what we used to call IT packs, which are prefabbed containers, if you will, of hardware and servers that just get dropped off at a data center. They get rolled up and they get plugged into three things: water, cooling, essentially, power, and bandwidth, and then they're off to the races in like a few hours. And it's an incredible set of technology. Today, they've moved away from this. You may or may not realize this, but the Azure data centers today are racks of servers, because what they've figured out is they can drive a little more efficiency, a little more power efficiency by going this path. And so now we're racking servers in data centers and that sort of thing. And so those are real shots from an Azure data center. So we got to build on that solid foundation. That looks pretty solid. If the folks that have been in an Azure data center know the security protocols to get in place, and you can read about them at the Trust Center. So one of the great resources that Microsoft provides is this Microsoft Trust Center that provides all sorts of information about how they deal with physical security, how they deal with compliance certifications, attestations, all of that available at this URL for the Microsoft Trust Center. So go check that out. But you can see on my slide here, I've just included the majority of the certifications, but I think Azure has more compliance certifications than any other cloud vendor, which is incredible. And they started out with the most difficult ones so that everything else was easy. They started out with all of the federal government certifications, and everything else is just kind of going through the process. So if you care about compliance and certifications for your workloads and your scenarios, it's great. Microsoft has a lot of these. We have customers that go from colos to Azure simply because it's much easier to deal with that physical compliance certification because it's just already there. Now, the next thing that I think is important is having good game plans and having a well thought out design, being neat and tidy, if you will, in your Azure environments. This is super important for security. We often come into customers that have been in Azure for a while that started out with like this Wild West sort of thing going on. You guys may know this, especially the folks that work in security. You guys probably stumble upon this stuff in your organizations. Like, what is that? Where did that come from? Like, oh, well, John over there, he decided to create a free trial of Azure, which created a brand new Intra ID or Azure Active Directory tenant that all the users are in. And we have all these subscriptions hanging off of this now figured out. So instead of doing that, how about we just think about this up front? There's a great resource called the Cloud Adoption Framework. It has all sorts of great guidance for how to do things in a way that's not going to end up in that crazy Wild West scenario that you have to clean up later. So you first obviously want to align your business goals and your business units with what you're doing. So you have to have strategy. But beyond that, once you get to that spot and you have great things going on strategically, then you have to plan well. And so when we talk about planning well, I think you guys are all here for a reason. I think one of the most important and overlooked areas of planning well for any sort of technology adoption, including Azure and including security in Azure, is education. You have to understand the platforms, the tools, the levers, the risks of whatever these things are to use them well and be effective. So education's super important. And when we think about these cloud sort of roles, there is a moment in here where you have to kind of retrain or retool because things are just different than what you're used to. And so this is a great diagram kind of just depicting this. It's in the Cloud Adoption Framework, but just kind of laying it out in real terms that, hey, you know what, this was your role when you managed servers on-prem, point and clicking through GUIs and whatever you did. But this will be your role going forward because things just change. We think about things in different ways. Infrastructure as code, scripting, automation. We don't think about servers like pets anymore. We think about them like cattle, all that sort of stuff, right? So I think this is important. There's two areas that I would point you to dig into and learn things about Azure well. So everything that I'm going to tell you about today, you can go dive into deeply and learn a lot. The first is the documentation section. And at first glance, or when you hear that, you probably think, oh, like I'm going to see reference documentation and boring stuff, and you will. Let's be very clear. You will see reference documentation in this documentation section, but you will also find all sorts of great resources, and you kind of see them here: conceptual documentation, architectural documentation, tutorials, quick starts, code samples. All of that is in that documentation section. The documentation section on Azure.com or Microsoft Learn is service-centric. This is important to understand. We are looking at, I zoomed into the documentation section for Microsoft Defender for Cloud. That is a service in Azure. All of that documentation is focused on and centered around a specific service. So you wouldn't see this overlapping into something like Azure App Services because it's a different service. However, there is another section on learn.microsoft.com that I think is extremely useful, and that's the training section. And this will go through scenario-based, modularized, self-paced courses where you can go learn things in a topical way that cuts across various services. And so this is really useful as well. You'll see here is courses on things like security and using Intra ID and all that good stuff. Then you've got your education laid down, your plan is well thought out and planned out. Now you're ready to go. What do? Well, you first have to think about how you're going to, again, keep things neat and tidy. How are you going to organize things in a way that makes it easy for you to manage, monitor, govern, enforce security policies, all that good stuff. And so having a neat and tidy spot to do that is super important. Also having a way to manage and govern things like access control and network security is really important. And so to do that, you have to think about things in the context of landing zones. I think you have to think about things in the context of landing zones. And what I mean by that is you want to build these kind of flexible, modularized environments, kind of micro environments in Azure or any cloud platform for that matter. So you want to build a micro environment, if you will, or a landing zone for identity. And you want that to be shared across all of these landing zones that might run workloads and applications. So the team over here that's building a CRM system, they need to use that identity system. And so they need to have a way in to use that shared identity model. We also need a network and connectivity space or a micro environment, if you will, a landing zone that deals with network and connectivity. And we want that to be connected to these other application-centric landing zones. We might have a management landing zone where we are enforcing policies and monitoring things, and we want that, again, to be connected to these other landing zones. And so in kind of like a hub and spoke model, you would build out a platform of landing zones, identity, network, connectivity, and management is generally the way we think about it. And then hanging off of that, we would associate those and link those with peerings to other application and workload-centric landing zones. This model is super important, and it's important to be able to kind of cookie cut this and deploy application landing zones over and over and over again that kind of align to archetypes of applications. That way you can define, here's what the policies are for this kind of stamped out environment for an application that looks like this, and hand that off to a workload and application team to go deploy. And so when we look at kind of enterprise landing zones, we see these big maps. We can zoom in and see things like there's a landing zone for an application or a workload. There's a landing zone for, or several landing zones that really describe the platform services that we're talking about, identity management, networking, and connectivity. And you might have multiples of those. You might have different identity solutions for different areas of your organization. We work with huge Fortune 50s, and so it's oftentimes that we have different connectivity landing zones or hubs based on how they want to monitor and tap that traffic and that sort of thing. And then in the middle, we have a way to govern all of this. And this is one of the pieces of magic here, because we are going to stamp out subscriptions for every one of these application landing zones. And somehow we need to bring that together in a unified kind of management plane. And management groups gives us this ability. So we can create a hierarchy of these groups, and you'll see this starting with that trusted root group down to different kind of levels. We have platform landing zones. We have the application landing zones. We have a sandbox over here. So the folks that want that Wild West sort of scenario, there you go. Have at it. Go deploy whatever you want in that sandbox. It doesn't mess with anything else. We can define all sorts of policies here to say, hey, we don't want any public IP addresses in a landing zone that is in that corp landing zone. There should be nothing that's exposed publicly. That should all be internal. And so we can define policies that would enforce that and govern that and apply those to hierarchies or nodes in this management group hierarchy. And so when I say we need to organize and be tidy and neat in our environments, we have to think like this. There is a hierarchy that's natural: management groups, subscriptions, resource groups, resources below that, and we have to manage these in this way. We can also tag these. In addition to the hierarchies, we have a way that we can tag these resources and slice and dice and filter these resources for security purposes, what have you. And then again, naming is super important, so we can recognize when something pops up in our SIM, we know like that's what that thing is based on this name, based on the tags that are associated with it, the subscription, where it lives, all that good stuff. And so I've linked again here to resources, a link here for a resource for naming conventions and that sort of thing. And there is some prescriptive guidance here. You don't have to follow it. In fact, we don't always follow this structure for naming conventions. It all depends on the scenario for a customer. We might move these things around. We might have the resource type at the end of the string or something along those lines. And oftentimes we don't use abbreviations for an Azure region like West US, because one of the things you'll notice is the region names have various links and letters. And so like Central US and West US are not the same length. And so oftentimes we will abstract these away and call this AZ1. AZ2 means West US. AZ3 means East US, that sort of thing. So things to think about as you're naming resources, just be consistent. Now, I mentioned I'm a big fan of DevSecOps. Everything we do, we automate. And I think as a good way to manage security in all sorts of ways, DevSecOps is critical. I want things in code. And again, this may push you outside of your comfort zone because you may say, hey, I'm not a developer. I don't want to write code. It's just the kind of future and where we're going when we're thinking about building systems at scale in the cloud. We describe all of these things in code with infrastructure as code tools. And so we think about DevSecOps in a continuum, if you will. This is one viewpoint of it with Azure tools like Azure DevOps. But if you're a GitHub person, there's GitHub tools. You could plug in whatever tools you would want in this flow. The important thing is we have infrastructure described as code. We are orchestrating it with some sort of tool that's managing the deployments. And when I say infrastructure, I mean everything: security policies, role policies, all that sort of stuff we would describe in code. That gives us a few things. One, we have a single source of truth. Whatever is in the repository is the truth. We have traceability. We know this thing happened on this day at this point in time. I no longer need like these crazy verbose like manual change logs that people are creating because the code is it. So it gives us all sorts of advantage in approaching it this way. This is one example. I'm not super prescriptive on how you do it. I like Bicep. It's a Microsoft language that sits over the top of Azure Resource Manager, or ARM. We used to describe Azure infrastructure using these JSON templates that were super verbose, and they're called ARM templates. Microsoft built this higher level abstraction over that called Bicep. It yields and builds ARM templates ultimately under the covers, but it's a nicer YAML looking way to describe these templates. It's not exactly YAML. It actually looks a lot like Terraform's HCL, if you're familiar with Terraform. They may have taken some inspiration from that, possibly. But this gives you a way to describe all your infrastructure and just say, hey, make it so. It's idempotent. So anytime you deploy this, it's going to converge the state to this state. It won't delete resources that are already there unless you tell it to, but by default it won't. And it won't overwrite these resources and recreate them. It'll just converge it into the state. So it'll make adjustments. If you say, I want to change the SKU that I'm using for this resource, it'll just change it in place for you. So it gives you a way to scale resources as well. And as we're talking about landing zones, in the slide deck are some links to GitHub repos that have resources for deploying, just as starter kits, accelerators for deploying enterprise landing zones with Bicep, with Terraform. There's also a PowerShell module there as well. All right. In addition to building our solid foundation through these kinds of principles, we also want to know what's going on in that solid foundation. Ooh. And if I go back, there we go. What's going on across our environment? I've just highlighted a few things here. Infrastructure, apps, network. There's a lot of things that we want to know what's going on in our environment. But visibility and observability is extremely important. When we get into that app stack, it becomes even crazier. I build a lot of distributed systems at scale, microservices solutions with customers, and they look like this and worse all the time. We have a sprawl of services. When we think about the cloud resources, we no longer think about resources like pets anymore. I don't think about a server named Luke or Leia or whatever it may be named. Back in the .com days, we did this. Like we had data centers full of servers named after Star Wars characters, and it was a blast. But it doesn't make any sense when we start thinking about those servers not like pets, but like cattle, just serialized servers that'll disappear and get reprovisioned and scale in and out and all that sort of stuff. I say that because we're no longer managing these things in a way where we are just RDPing to a server and saying, hey, show me what's going on that server. Give me some insight into the health and the logs and what's going on. Instead, we have to observe that in a centralized way. And so this is just an example of microservices solutions that bring that to becoming a need. In Azure, the core of all of the Azure observability is an Azure Monitor. It wasn't always this way. If you've been around since the early days like me, you know that back in the day, every service had its own way to log and show telemetry and metrics and all that sort of stuff, and it was a nightmare. Over the last several years, Microsoft has unified this, and it's still a work in progress. So don't let the marketing people lie to you. It's still a work in progress, but they are making it better and better and better all the time and unifying it under this one Azure Monitor solution. Azure Monitor, like monitoring data really is two types of data. We have logs and metrics. That's really it at the core. And so we bring all that data into our platform where we can do all sorts of great analytics over that data, querying that data, alerting over that data. And then on the outside, on the backside, if you will, we have things like insights, where we can glean insights from all of that logging data that happened. We can visualize that in a bunch of different ways. Workbooks right inside of the Azure portal, Grafana. We can analyze that data with log analytics right inside the Azure portal, and we can send that out to other sources. So if we want to send that log data to a SIM that we have that is not in Azure even, we can do that. We can tap into an event stream and ingest that data into some other tool that we're using. All right. And just as a couple of viewpoints of this is what you would see in the Azure portal in Azure Monitor for just telemetry data like metrics coming out of like a virtual machine, for example. This, in fact, is a screenshot from a virtual machine. One of the cool things that Azure Monitor and Application Insights gives you is just an inferred kind of directed graph of communication that occurs through your solution. So it's monitoring HTTP requests and that sort of thing through your system. And it's saying, hey, I understand that this virtual machine is talking to this Azure SQL database, talking to this storage account, this service bus namespace, what have you, and it will show you that. And then I can see errors in that kind of view, which is great for observability and trying to understand what happened after an incident. And then I can query that data. I mentioned log analytics. I can query that data with a specialized query language. It's not SQL. It's called Custo Query Language, KQL. So you have to go figure that out and learn it, but it's not super difficult. In fact, in some ways, it makes more sense than writing SQL in the way it's structured. But you can query that data and do all sorts of great things, slicing that data and reporting on that data. And then you can generate notifications and alerts based on these queries you've written. So if you have a query that says, hey, when this thing happens, I want to know about it, great, send me an alert. And I want that alert to push a notification to my mobile device, send an email, that sort of thing. And I can do all of that right inside of Azure Monitor. All right, so we have our solid foundation. Cool. Now let's think about our surface area for attack in Azure. Has anybody created a Azure free trial recently? Okay, that's awesome. A few folks. Then you've probably like seen me after you've created an Azure free trial, because they dump you out to a series of videos that I created for Azure.com that walks you through getting started with Azure and all this fun stuff. So I'm right there in the Azure portal. When you do that, it guides you through the simplest of paths to get you started quickly doing things. By design, they want you to get started quickly, but it might not be the best thing for you to do, especially from a security point of view. So let's talk about what a typical application looks like. We're going to talk about it in an infrastructure way, like virtual machines, all that good stuff. Because this is the most common thing that runs in a cloud platform is VMs, even though there's all these great PaaS services to take advantage of. So a typical application, I refer to this as box arrow, cylinder. It's what I do on whiteboards all the time. But we have a web server talking to some sort of application server, talking to some sort of database server, whatever that may be. It might be relational data, it might be NoSQL, it might be file systems, it doesn't really matter. But that's what our typical application looks like running on servers in a data center. And when we deploy this to a cloud, specifically Azure, we get this kind of thing. We might throw in a domain controller in there too. And we want to connect to those resources to manage them, to administer them. And so when we do that, we just connect, just RDP, SSH. We just put public IP addresses on these guys and go to town. That sounds terrible. In fact, in the early days of Azure, when Azure Infrastructure as a Service came out, VMs came out, they defaulted the username. So the username was defaulted to administrator. The only real way to connect in and the way they would guide you through the portal was to put a public IP address on the thing or run it through a load balancer. And so these machines would get taken over by kids using TS Grinder before they were ever like connected to by the person who actually deployed them. And so Microsoft realized, hey, this doesn't really work. In fact, we shouldn't default the username. And furthermore, we shouldn't even allow administrator to be a username or admin or root or guest or whatever. So there's a banned list of usernames that can be on these machines. We have to have a local account to begin with before they're domain joined. But if you're familiar or not familiar with TS Grinder, it's a fun toy. It's a fun tool. You can quickly and easily brute force VMs through RDP, because RDP, the way the protocol works is it lets you establish a channel and just continue communicating over that channel. And so nothing looks malicious in that communication because they're not seeing what's actually being passed over that channel. And so you can really just go to town and brute force access to a local account on a VM pretty easily with this. So, go play with this. I'm not encouraging you to do malicious stuff with it, but there it is. Do you? With that, let's not do that. So instead of doing the file new project sort of thing, or just walk through the wizard in the portal and create a public IP address on this VM and open up RDP and SSH to the world, how about we don't put public IP addresses on these at all unless we absolutely have to, but definitely don't open 3389 and don't open 22. Let's not open RDP and SSH. So instead, everything runs inside of a virtual network in Azure. You define the address space. It's your own private network. You can define the subnets within that network in the address space. And you don't have to put anything public on it at all. We could just create a VPN tunnel into that. And there's a few ways we can VPN into that. The first would be through a point-to-site connection. That connection is really you having a client of some sort running on your machine. So an Azure VPN client, Open VPN, whatever it may be. And you are going to authenticate with credentials, a certificate. I would recommend using Intra ID credentials. But the certificate mechanism was there to begin with, so people still use it. You're going to authenticate in that connection. You're going to establish a VPN connection, and now you're in, just like you would be any other client-based VPN connection. Cool. That's great. But that doesn't really deal with how we want to maybe bridge our data center and have a hybrid cloud scenario. So what if we wanted to have a persistent, always-on, site-to-site connection between our data center and Azure? We can do that as well. There's a site-to-site VPN tunnel. We can create IPsec tunnels to gateways and firewalls in our data centers or colos or wherever we're running, and do the same thing using an Azure Virtual Network Gateway or VPN gateway in Azure. So we can establish that persistent connection. We can establish multiples of these too for high availability and failover as well. If we wanted to take it completely off the public internet, so that VPN tunnel is encrypted and all that good stuff, right? But maybe we want our own private circuit connecting in. We want to work with our telco and say, hey, just create us our own lane right into the Azure data center. We can do that. There's a service in Azure called ExpressRoute. With ExpressRoute, you get your own MPLS circuit, dedicated, consistent, predictable connectivity. It's highly available. There's a pair of connections in that ExpressRoute circuit. So by default, it's highly available. And you have your own kind of dedicated circuit right into the Azure data center. It's expensive, generally, compared to like a public internet VPN tunnel. So just be aware of that, but you can do this, and we have a lot of customers that do this. And you can even fail over to a VPN tunnel if for some reason that ExpressRoute circuit goes bad. You can have a couple of pathways in. So now we're getting rid of those public connections into our data center via RDP and SSH. That's great. We've got everything private, locked down, all good stuff. We've reduced the surface area of attack. You're probably going to create a jump box in kind of a DMZ, I would imagine. A lot of people are going to do that. And then control the network traffic from there. Well, instead of doing that, Microsoft has a service for that too. And that's called Azure Bastion. It's not super new, but it's relatively new compared to all of these other capabilities. And what Azure Bastion is a jump box as a service. You no longer have to maintain and manage that infrastructure. You just tell Azure, give me a jump box as a service, give me a Bastion. And then you have 443 connectivity through a web portal into that Azure Bastion service. You're going to authenticate with your Intra ID credentials, and then you're going to authenticate to the boxes from there. And then there's a private tunnel between Bastion to your network and VMs. So again, you're not exposed to the public internet in any way. Bastion is brokering that just like you would do with your own jump box. You just don't have to manage infrastructure. So this is a great thing. I would encourage you to check this out if you're not using this today. And you need to have remote connectivity to that infrastructure publicly. You can do that through Bastion. All right, so we've reduced our surface area. Now I've mentioned something a couple of times, but I want to strengthen this gate. And so this gate is really, if you think about a gatekeeper, it's the thing that's making sure that we should be able to come in to this environment. You know, it's checking our credentials and all that good stuff, making sure we're authorized to come inside this wall and into this fortress. Intra ID is the solution for that in Azure. Again, wasn't always the solution in the early days, but it is today. And if you're not familiar with the term Intra ID, that's okay. It's because Microsoft renamed this too. Used to be called Azure Active Directory. And so recently, Microsoft, maybe in the last year, renamed this to Intra ID, which I'm actually a big fan of. Anybody love the Azure Active Directory name? Right. It's confusing. Let me explain why I think it's confusing. This is not an Azure service. This is a Microsoft identity service that spans lots of things. So the Azure moniker makes no sense. It's also not Active Directory. And so customers come to this thing and say, hey, yeah, cool. I want to get rid of Active Directory on premises. I'm just going to use this Azure Active Directory. And then they realize, hey, this thing doesn't do what Windows Server AD does or Active Directory domain services. What's up with that? So instead, we got rid of both of those confusing elements and we just renamed it to Microsoft Intra ID. Cool. Intra ID is the identity solution you guys are all familiar with, and I'm sure it's what we're authenticating with and logging into to connect to Microsoft 365, Dynamics 365, and also Azure. It is what underpins all of the identity and access control in Azure. This is super important. It's super important across everything you do, both Microsoft first party, but even third parties. We can extend this out to third parties as well to use this as the identity provider for those solutions. So it's super important to make this rock solid and secure. I really just can't stress that enough. And we expect Microsoft to always deliver this, to be always on, because it's super important for us to use anything. Like we can't even log into Teams when this thing goes down. We've seen that before. So a couple of things that I would encourage you to do. Legacy authentication. Now, you may say, well, this is just blocked by default today. And you're right, it is. As of 2023, like January 2023, they finally killed it in December of 2022. They permanently blocked legacy authentication. So all of the old clients like ActiveSync and all the things that needed to connect to Exchange, they blocked all of those legacy protocols so you can no longer just pass across those passwords in that way, increasing security. Because like 97+% of the attacks that were happening, password spraying and all that good stuff, were happening with those legacy protocols because they just don't have the same sort of security that the modern protocols have. So they killed it. Except for, there is a caveat, it still works for SMTP. Because apparently there are printers and scanners out there in the world that need this ability for SMTP legacy authentication, which in my mind, if I'm Microsoft, like I guess I'm just providing you tools and you hurt yourself however you want. But in my mind, I would want to just kill this off and say, hey, go buy a new printer, right? Figure it out. But they haven't, so it's still available. So if you don't have those old printers and scanners and you don't need this, make sure that you have this disabled for your organization, for your tenant, because this is a great vector and surface area for attack. Now, sometime back, we decided that we can solve all of the identity problems. We can solve all of the account stealing problems and stop all the hackers by just adding MFA. Solves all problems. I hear chuckles. Doesn't solve all problems. In fact, if I had time, we would play around with some tools and I would have a lot of fun and impersonate your sessions and all that good stuff. We don't have time for that. But I will point you to those. So MFA does not do that. And why? Well, there's various reasons. One, MFA fatigue. What people realized is if all you have to do is just say approve, 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 if I just ask you to approve a bunch of times, it's kind of like when your kids say, hey, Dad, can I have this? This is my 15-year-old son here. So I don't want to give him any clues. But when they ask over and over and over again, and eventually you either get super mad and like, that's the end, or you're just like, yeah, whatever, like do that. Well, that's what happens with MFA fatigue or just kind of blasting away with MFA prompts. And eventually people are just like, yeah, whatever, like approve. I don't know what it is, but fine. Well, instead, we have capabilities where we can kill that off completely. I would encourage everyone to use the Authenticator app for MFA prompts, not SMS, not other challenges that exist. Use Authenticator, number matching. I have to come in and say, okay, cool, the number is 66, all is well. Does this solve all of our MFA problems? No. People are shaking their heads no. Does anybody use this? This is a blast. If you haven't used this, when you get home over the weekend, if you're not at the gaming convention upstairs or wherever it is here, check this out. Play with it. It's fun. Evil Jinx is a adversarial, like man-in-the-middle proxy that you can just put this thing in place, put a domain on it. I have one that's super convincing. It looks like MicrosoftOnline.com, but it has an extra letter in it. It's super convincing. And so I can just say, hey, log into MicrosoftOnline.com, point this to that. I can create a Microsoft 365 login prompt here. I can phish you and make a compelling reason why you would want to log in. And I'm sitting in the middle of this whole thing. And you say, well, that's cool. You intercept my password. That's great. I do. I intercept your password. And then I give you this. And I say, hey, give me that number too. And you just willingly give me that too. And then behind the scenes, Evil Jinx, which is just a proxy, it's sending all of those payloads back to Microsoft, brokering them, sending them back to you. And then in the middle, it's capturing the cookies and the token that got passed back. And so when I see that, I go grab that token, and now I'm logged in as you. And I'm going to do some OSINT stuff to begin with, right? I'm going to figure out what the right people are to target an organization that's going to give me global admin access, right? And then I'm going to go create my own accounts, and I'm going to create my own application registrations in your tenant, and I'm going to have access to stuff that you don't even know I have access to for a long time, right? So how do we protect this? How do we prevent this? And just so you kind of see what happens behind the scenes, this is a screenshot of what happens behind the scenes with Evil Jinx. So I have fishlets here in the middle of the screen. And in this case, there's a Google fishlet here. I can create all sorts of prompts to fish with. And then down below, you'll see the hits on that fishlet. And so you'll see a session there. So you'll see session ID. I can't read it. It's too small, but whatever that session ID is. And then I can request that session, and it will spit out all the information for that session, including down at the bottom, you'll see that cookie. All I have to do is copy that into my browser, and now I'm you, right? So how do I prevent this? One way is FIDO2 keys, right? I would encourage you to, in addition to the authenticator solution, use something like passwordless with FIDO2. That's one way to deal with it. The other thing is conditional access. This is kind of a view of what conditional access is doing. We're gathering. This is taking signals from all sorts of inputs and holding on to them and doing intelligent things with them. It's then taking those signals, making decisions based on the signals that came in. So you are logging in from Wisconsin and you are logging in from Florida at the same time. That doesn't make any sense. You are logging in from a device that isn't trusted. I'm taking these signals in and I'm doing something with it and making a decision to enforce a policy and maybe not allowing you to connect. Maybe you're trying to connect without MFA. I'm enforcing MFA on you, that sort of thing. So through conditional access policies, I can force these things and say, I need MFA from you, or based on your behaviors, I actually need you to true up and authenticate again. I need your password again. I need a full-on credential prompt here and challenge for you to log in again. So I can do those kinds of things. The very first thing on this list, and again, you'll have these links in the slides, so don't feel like you have to jot them down or something like that. But the very first thing I would recommend people do before starting to screw around with conditional access policies is to create an emergency break glass sort of account. What I mean by that is an account that is excluded from these policies. And so you're going to create the longest kind of username in the world that doesn't make any sense for your tenant. You're going to create the longest password in the world that doesn't make any sense. You're going to print that out. You're going to fold it up and put it in your safe or whatever you do with it. And then you're going to rotate it periodically because it's a risk, right? Because you have an account sitting there that somebody could log in with without MFA. But you want to exclude it from all of these policies because when you're creating these policies, you can brick your tenant. You can exclude and make it possible for you to never log into this thing ever again, right? You don't want to do that. So that would be the first thing I would recommend. Then there's some best practices that I would encourage you to check out. There's an example of how to require MFA for all users. A lot of times people look at the example to require it for admins, and then that's as far as they get. No. Like require it for everyone. And then instead of doing the silly thing that we do, like I'm to onboard a new user and their first password is going to be responsivex123. Don't do that either. You can onboard to MFA and the authenticator MFA challenges using temporary access passes with Intra ID. Do that instead. Don't even leave yourself a window of time where some screwy general purpose always use password is available for somebody to spray or something like that. All right. I'm gonna burn through some things really quickly because I want to point you to a bunch of things. We want to add defense in depth. We want to add layers. We want to add moats. We want to add walls. The simple things we know: Windows firewalls, Microsoft Defender firewalls on nodes. That's again just defense in depth. We want layers, right? IP tables, firewall D on Linux. Maybe it's a third-party solution that you use. Put those controls in place on the nodes. Then at the network fabric layer, everything in Azure is software-defined networking, but we want network policies as well at the network to say, hey, I want to only allow this source address to connect to this source address over this port, over this protocol, or I want to deny all of that, and I can do that through network security groups in Azure. That's essentially firewall policies. I can do north-south policies as well as east-west policies here, and so I would encourage you to do that. Additionally, there's a service called Azure Firewalls. You see it in the middle of my screen here. That will let me do both inbound and outbound all the way up to layer 7. And so I want to protect against data exfiltration. And so maybe I only want to whitelist the known domains that I should allow things to connect to, so I don't end up in a C2 situation where SolarWinds got compromised and they're exfiltrating data out of my data center, like whatever it is. I want to prevent that. And so Azure Firewall gives me that capability. We all know we need a secure communication channels, right? TLS and HTTPS. We all know this. I was working with a customer recently that essentially does think about it like casino games. That's what they do. And they had everything running over TLS, but they were passing all sorts of sensitive data in the URL. And again, it goes back to education. The developers thought they were doing the right thing. Like, oh yeah, it's TLS, HTTPS, it's all good. Like, yeah, except for that URL is seen everywhere. And so they thought they were doing the right thing, but in fact, they were passing sensitive information there such that somebody could compromise that and did, so that they could pass in things to get free money, essentially. So we fixed that. So don't try to figure it out. Don't OSINT me and try to figure it out. But you got to just make sure you're doing the right things. Even if you are layering on the right technologies, make sure you're using them appropriately. Least privilege, I told you we'd talk about least privilege as well. You got to distribute secrets with caution, manage access appropriately, and there's great ways to do that in Azure. Policies for secrets, but there are lots of secrets to think about, especially because of the history of Azure. So we have all sorts of keys all over the place in Azure: storage account keys, Cosmos keys, IoT Hub keys. And so we have to somehow protect these, policy them, rotate them, that sort of thing. One option is to store these off your compute node out of your applications in a service like Key Vault. It's an HSM, managed HSM, in fact, for you, fully managed, so that you can store keys, secrets, and certificates and not have to manage that and store those sensitive pieces of information with your application. Even if it's in configuration, even if it's in a certificate store on the node, you can extract that out to Key Vault. Cool. Then the question is, okay, well, if I have Key Vault, that's great, but somehow I have to authenticate to Key Vault. So I still have to have a secret, right? Sort of. Let me push play again. Azure has built into the fabric of Azure this concept of managed identity. It's essentially like a service account that runs in the fabric of Azure with your application. So you have a virtual machine, you run it as this identity. It's not the logged in account for the VM itself, it's the service that runs in Azure. You have an app service or a container, whatever it may be, it has an identity attached to it. So now when it accesses or tries to access Key Vault, I know the identity of that and I can allow it to access that without having any secrets in my application tier, in my code on the node. The fabric of Azure just deals with that for me automatically. So managed identity, if you're not using managed identity, it gets rid of the need for all of those secrets being stored and passed around everywhere because it just happens at a much lower level that's baked into the fabric. Role-based access control as well. So using these service principals and identities, using managed identities, using your interactive user service principals, I can apply role-based access control. So I want to have least privilege to my Azure resources. I see this all the time where it's just easy for someone to say, let's just make all of these people owners of a subscription. And it's like, no. Why? Like that you're just opening up yourself for a huge surface area for attack when one of those accounts gets compromised. So provide the right granular access. You can even create your own role definitions. So you'll see here, it's just a collection of permissions and it's defined in JSON. So you can say, I want a role definition that has these explicit permissions and only this, and then grant that to users. So make sure you're taking advantage of role-based access control. And then we talked about that whole management group structure earlier. I can use Azure policy to enforce these things. So I can define policies with those rules, apply them to management groups, apply them to subscriptions, to resources. I can scope it however I need, and then enforce things are happening. So for example, I want to say, I never want to allow anyone to deploy a virtual machine with a standard G whatever SKU or size for the VM. I can create a policy to do that, and it will just block it. Or if somebody tries to put a public IP address on a VM, my policy is going to show up and say, absolutely not, get out of here. I need to encrypt data as well. So things like disk encryption are super important. And you'll see my screenshot here that says, hey, we've not encrypted these disks. This is telling you to go ahead and light up disk encryption. It's going to use BitLocker behind the scenes or dscrypt on Linux. I can also encrypt data at the data platform, data services level. So like Azure SQL Database, this is a screenshot of Azure SQL Database turning on transparent data encryption, which is going to encrypt that data at rest. But I also may want to encrypt that data in transit, not just at rest, and in memory in the database. And so there's a feature in SQL called Always Encrypted that allows me to do that. Transparent data encryption, if you're not aware, just encrypts like the LDF and MDF files and backup files that are sitting on the system, but the database itself has the data in plain text. So Always Encrypted gives me the ability to not have that data in plain text because the keys are sent to the client. And then lastly here in this block is confidential computing. This is incredible because what you're getting is a secure enclave that no one can peek into on the hardware of the VM. So if you have a super sensitive situation where you want no one to peek into the memory and the data that's running in that VM, you will have a secure enclave with a trusted execution environment that no one can peek into that, Microsoft or otherwise. So that's pretty incredible. All right, we are out of time. There's actually two more things I want to call your attention to, and that is Defender for Cloud. If you're not familiar with this, check it out. It's providing guidance for improving your security posture in Azure. It used to be called Azure Security Center, and so it just surfaces up in a priority fashion recommendations based on what it observes in your environment. And then the last thing would be if you don't have a SIEM or a solution, like a SOAR solution already in place, Azure Sentinel is the first-party solution running in Azure to provide those capabilities as well. Again, you can use whatever third-party solutions you have. If you're using Logarithm, Splunk, whatever it may be, you can continue doing that with Azure, but this is a solution built right into Azure. If you are an app dev, some folks raised their hand, you're an ASP.NET developer, I could talk about security for a long time, and I get to, coming up in, I don't know, September? Yeah, September, specifically for application developers. So if you're curious about securing and hardening your ASP.NET web applications, you can come join me here at this event. It's a virtual event online, but you can register. There's the link, and again, hit me up. There's my email address if you want copies of these slides. Thank you so much. This has been a blast and lots of fast-paced fun stuff. So thanks.